Hey guys, here is our Algebra 2 Unit 3 Part 2 review. So I'm not going to be doing every single problem on here, but I'm going to try to go through the main problems just to kind of help you prepare for your test. So the first one that we're going to do together is this one, because this can be kind of a tricky idea here. It says graph the function y equals x squared plus 9. So this is in standard form, which means it's in that y equals ax squared plus bx plus c form. And what we would normally do whenever it's in standard form is we would use x equals negative b over 2a, because that's going to help us find our x value, our axis of symmetry. So since we're missing our b value, because notice there's no x term, then what we would just have is 0 over 2 times a value would be 1, which ultimately is just 0. So that tells you that your axis of symmetry, let me do it in a different color here, that would be along the y-axis here. So our vertex is going to be on the y-axis. So our vertex x value, remember, these two are always the same. Your axis of symmetry and your vertex x value are always the same. And then to find that value, all we do is we take our x value and we plug it in. So it's going to be y equals 0 squared plus 9, which is 9. So 0, 9 is our vertex. So that means our point is up here at 0, 9. Okay. Next thing it says, maximum or minimum, circle 1, and then what is the value? So this would technically be a let me back that up. Minimum point, because it is the lowest point, because our parabola is going to open up. It's a positive a value. And the value of that, so if you would put y equals 9, or if you wrote the coordinate 0, 9, okay? But we're mainly looking for that y value, which is at 9. Now, the roots part of this is tricky, because we know that this would go up. The roots part, just let me remember we would do our table x, y, a times y, 0, 1, 2, 3, 0, 1, 4, 9. And then the third column would be 0, 1, 4, 9 as well, because our a value is 1. So we don't even really need the third column. But so we would go over 1, up 1 on both sides. And then this would actually go up. So the rest of it's going to go off the graph. You just need a few points there. But the reason is because when we look at our roots, we don't actually cross the x-axis at all. There's no points that are going over there. And if you remember, if you have a situation where you don't cross the x-axis, that means that you're going to have imaginary solutions. So what we do is we look at our original equation, and we want to find the zeros or the roots. And to do that, we replace our y with a 0. So then we'd have 0 equals x squared plus 9. I'm trying to solve for x squared. So let's move that 9 to the other side. We'd have negative 9 equals x squared. And then we would take the square root of both sides. Now you have to remember that technically it's two solutions here. It's plus or minus, and then 9 we know would be 3, but since it's negative 9, we include 3i. So your roots are x equals plus or minus 3i. We have imaginary solutions because it doesn't cross the x-axis. The domain here is going to be all real numbers. Even though we have imaginary roots, we're just looking for the input of real numbers in order to give us the parabola. So we're not going to be worried about anything differently there. The domain's just always element of the real numbers. And then the range is going to be it's going up, so it's greater than or equal to our y value of 9. Okay. All right. So we just did that one. I kind of did the harder version of that. But remember, for this one, this is another standard form one, so you're going to still use that x equals negative b over 2a. I'm going to let you try this one because I went through the process of a standard form one that is a little bit tougher on number 1. Okay, now let's take a look at number 3. Number 3, this one is the intercept form or the factored form. So our axis of symmetry here, we need to plot our points. So x minus 4 and x minus 7, that would mean that we would have two solutions. We would have one at, I'll actually just write it down here, 4, 0 and 7, 0. So I'm going to go over 4, and then I'm going to go over 7. Now this one's kind of tough here. Not an ideal problem because we are trying to find the middle of 4 and 7. And if I take 4 plus 7, divide that in half, I'm going to get half of 11, which is 5.5. So my axis of symmetry here is not the nicest number. Basically, it's going to be in between 5 and 6. So my axis of symmetry is x equals 5.5 or 11 halves. So I would get 5.5. And then what I need to do is take that value and replace my x values. So 5.5 minus 4, 5.5 minus 7. And I'm going to plug this in. This is one I would suggest plugging in your calculator. So let me just pull up my calculator really quick. Let me get the other one. There it is. Come on. Okay, so I would have 2 parenthesis 5.5 minus 4 parenthesis and then 5.5 minus 7. And we get negative 4.5. So we'll make this work. It's not the nicest table ever, but it's going to work for what we're doing. All right, so that is 5.5 negative 4. So I'm going to go over that and then down 4.5. So about right here is my vertex. Now notice for this one, I don't even need to make a table because I know where I'm going to go next. I'm going to go through these points right here because those are my intercepts. And I know it's going up because I have a positive value of 2. That also tells me that I'm going to have another minimum value. That minimum is the y value of negative 4.5, or you could write the coordinate for the vertex because that's the lowest point. We already filled in the x-intercepts of 4, 0, 7, 0. And then our domain is still all real numbers. And our range is y is greater than or equal to that minimum value of negative 4.5. Okay, so there's a y-intercept example. This one here is the vertex example. I'm going to let you guys go through this. This should be the one that is the easiest. But if you need to review, look back at our very first set of notes for this half of the unit. Remember that your vertex, I'll just get you started here. This is your h, this is your k. Your h is the opposite, k stays the same. So that tells you that your vertex is negative 6, positive 3. And then our axis of symmetry would be negative 6. So I'll let you go ahead and fill out the rest of this, but hopefully that gets you started. Okay, now notice we have solve the following quadratic inequality algebraically, show all of your work. What we're going to do for all of these, they are all factorable, and you don't need the box method for any of these. So we're just going to jump straight into this. I'll just do the very first one because they're all going to be very similar. So let's look at number 5 here. So x squared minus 6x minus 16. Since that should be factorable, I'm looking for factors of my last number, which is negative 16. So factors of negative 16 that combine to make negative 6. And if you think of it like that, you know that your factors are going to be positive 8 and negative 2, because they multiply to make negative 16, they add to make negative 6. So I'm going to have x plus, not plus, sorry. I actually did this wrong. Let's backtrack there. I apologize. That's why you always got to think about your work. Negative 8, positive 2. So minus 8, x plus 2. Then, since this is an inequality, we are trying to find the two values that would go on our number line here. For this one, I want to think of my x-intercept as positive 8, and this one would be negative 2. It's going to be the opposite sign because that's what would make it 0. So then I would have negative 2, positive 8, and since it's less than or equal to, I'm actually going to have a closed circle on both of these. You want to distinguish whether it's closed or open. If it had just been less than, not the equal to, then we would have left it open. Okay, so now that I got those points, now I just need to decide, is it going to be between those two, or is it going to be on the outer parts? So is it going to be in between the points, or is it going to be here and here? So basically you have a 50-50 chance. The way that we're going to figure that out is we're going to test a point in between. Conveniently, 0 is a great point to test. I like to go back to the original problem when I test these. So if I replace my x with a 0, I'd have 0 squared minus 6 times 0 minus 16, and I want to see if that's true. Is that less than or equal to 0? Well, this would be 0, 0, and negative 16. That is, in fact, a true statement. So if it's true and 0 was between those points, I'm going to shade in between. So my values here would be the answer. Or if you're using your pencil, you can just kind of shade that in. But all the values between -8 and, or sorry, -2 and 8 are going to be true. And if you think of like the parabola shape, if I actually draw a parabola here, let's imagine it crossed there and there. Everything underneath here, all those y values would be less than 0. So it makes sense that it is between for this problem. Okay, so thinking about that and thinking about the problems you've practiced in the past, go ahead and do number 6 and 7. You can always check back to the notes or the video for that. All right, getting to the end here. Number 8, I'm just going to do that one with you. Write a quadratic equation in vertex form whose vertex is 3 units right and 4 units down of the graph y equals 2, x plus 2 squared plus 5, and whose graph is narrower than the function. So there's a couple things we need to be cautious of. Remember, the vertex form is y equals ax minus h squared plus k. So that's how the equation right now is written. We want to make sure to take note of that. What I always like to do is I like to start off with the vertex. My vertex here is currently -2, +5, because it's the opposite of +2. And then I need to move that 3 units to the right and 4 units down. So what I'm going to do then is if I want to move it to the right 3, I'm going to add 3. And if I want to move it 4 units down, I'm going to subtract 4. So then my new vertex is going to be -2 plus 3 is 1, 5 minus 4 is 1, and I actually get the coordinate 1, 1 for my new vertex. The next thing that I need to be careful of is I need the graph to be narrower. So what it means to be narrower is to stretch it out. So it needs to increase at a faster rate than what this one is currently increasing at. So I actually need a number that's bigger than 2. That's basically all that it's asking. So then if I'm going to pick a nice number that's bigger than 2, why don't I just pick 3? So instead of a value being 2, I'm going to change that to a 3. And then I would have x minus 1, because remember, it's the opposite of your h value, squared plus 1. This is not the only equation that works. Remember, the vertex would have to be 1 and 1, but our a value could be 4, 5, 6, anything that's technically going to make the function narrower. But I'll just do this as a simple example. Okay, and then we have 2 here that says write a quadratic function in the specified form whose graph has the given intercepts. So there's one with vertex form, and then there's one with intercept form. I'll do the one with intercept form because that's a little bit more challenging. The vertex form, hopefully after looking at that problem we just did, it'll kind of remind you about the features of the vertex form. So for intercept form, that is going to be y equals a x minus p x minus q. So we're just trying to find like our p and q, and we actually see those here and here because those are the x-intercepts. So right now what this is saying is y equals our a value, and then it's x plus 2, because it would be the opposite of -2, and x minus 4, because it's the opposite of positive 4. And the last thing we need to do is solve for our a value. So then what we're going to do is take this coordinate here. That's our x and y pair. So I'm going to plug that in for x and y with what I know so far. So instead of y, I'm going to replace that with 4. My a value is what I'm solving for. And then I'm going to put 2 plus 2 and 2 minus 4. I just replaced those x values with 2. All right, so 4 equals a, and then it's parentheses, 2 plus 2 is 4. 2 minus 4 is -2. And then I'm actually going to multiply these two together. So I get 4 equals, it's a times -8, but it might be easier if you read it as -8a. These are the same thing. And then to get a by itself, I'm just going to divide by a -8 and be really careful. -8 is the bigger number, and that's on the bottom. So your answer is going to be a equals -1/2. It's okay to have a fraction. And that means that our final answer, so we're going to look back at this line right here. Everything's the same except we know the a value is now -1/2. And then it would just be x plus 2, x minus 4. So when you're doing number 9, it's similar, but you're using the other equation, the vertex form equation, which is this one right here. Okay. And that is it for the review. So go ahead, fill out the rest of those problems, and then make sure to submit this for credit for your review points.